You can link many of our great cities with one industry. Manchester, cotton, Sheffield, steel, Glasgow, ships. But Birmingham is harder to pin down. Why did this city become the Industrial Revolution's #1 manufacturing centre? A bunch of metal bashers. That's the old cliche about the tradesmen and tradeswomen of Birmingham. But you need skill, as well as brawn, to make chains like this. Birmingham was never a one-trade town because the Brummies could turn their hand to so many tasks.
Birmingham's success story begins here, in small family-run workshops, getting their raw materials from the surrounding area, which became known as the Black Country. It was this combination of metalworking skills and access to local coal and iron which were to drive Birmingham's rapid expansion. Traditionally, cities grew up slowly around old cathedrals or ports, but the Industrial Revolution was to forge a new type of city, built on trade and industry.
What really gave Birmingham its industrial kickstart was the coming of the canals. Until the mid-18th century, Birmingham stood isolated on a plateau 60 metres above the surrounding countryside, which was filled with coal and iron ore deposits. It needed to make a connection.
And it was the local traders who took the initiative. In 1769, they commissioned James Brindley to build a canal, connecting the nearby coal mines to the town. The price of coal halved, cutting costs in the metal workshops.
In those days, the canal meandered through villages with names like Farmer's Bridge, Wensbury Oak, Rough Hills, Pudding Green. But these places all became hives of industry, and Birmingham began to boom.
The timing was perfect. The growing middle classes were spending their money on fashionable jewellery and trinkets. Small, finished goods, ideal for bulk transport on the new canals. And Birmingham had a unique advantage over older established cities like London. There were no charters, no guilds, no heavy bureaucracy. It was a commercial free-for-all. If you had the skills, you could set up shop and start manufacturing. And labourers from the surrounding countryside swarmed into the town looking for work.
This was the place to get your hands dirty and make some money.
Ideally placed in the centre of the country, Birmingham quickly became the hub of an extraordinary trading network, linking to the Liverpool docks via the Trent and Mersey Canal, to Bristol via the Severn, and eventually down to the Thames and London.
You can see what happened to the town after the canals were built from these maps here. It boomed. It went from 4,000 to 90,000 in just 30 years. And it became more respectable, which is why it's probably called Birmingham instead of Brummagem, which is what the locals call it. All right, chick.
One man who exploited everything Birmingham had to offer and engineered his own industrial revolution was Matthew Bolton, the great entrepreneur.
He set up his works here at Soho on the canal side. And he made brass goods and buttons.
But it was his collaboration with James Watt, the father of the steam engine, that really put Birmingham on the map. Fascinated by steam power, Watt moved from his native Scotland to Birmingham, attracted by Bolton's entrepreneurial energy and his skilled team of Brummie metalworkers. In 30 years, they dispatched over 500 steam engines via the canal network to mines and factories all around Britain.
As Bolton said to James Boswell, "I sell what all the world desires. Power."
People came from all over Europe to see Bolton's state-of-the-art manufactory.
And his house at Soho became home to the Lunar Society, a collection of brilliant, independent-minded visionaries who met on the first Monday after the full moon so they could find their way home after dinner.
They discussed everything, from the chemistry of glass manufacture to the origins of the human race.
It is my belief that the human body is governed by electricity.
They were the intellectual driving force of the town. An 18th century think tank, the Lunar Society kept Birmingham at the cutting edge of science. Above all, it was good for business.
Matthew Bolton, manufacturer, astronomer, man of taste, and guiding light of the Lunar Society. Dr. Erasmus Darwin, scientist, inventor and poet. I invented a front-wheel drive for horse-drawn carriages and devised a theory of evolution before my grandson Charles was even born. Dr. Joseph Priestley. I discovered oxygen and experimented with electricity. Samuel Galton, manufacturer, promoter of canals, maker of guns, and a Quaker. Tough, no-nonsense, hard-headed businessmen and scientists. They exchanged ideas and information and paved the way for Birmingham to become the #1 manufacturing centre. Birmingham was coining it.
Bolton was always quick to spot an opportunity. In the 1790s, rapid inflation created a national demand for coinage. So he set up another production line, using steam power to revolutionise coin making, a trade still carried on in the city today.
This is the Birmingham Mint, the biggest independent mint in the world. Thank you very much. And there's a direct link with this mint and Matthew Bolton, because they started using Bolton's steam coin presses, which could produce 120 coins a minute. This one here can do 750, and at the moment it's producing euros. Rummies, see? One step ahead of the game. But the noise level's probably about the same as the early 1800s. The poet Southey visited and said, "I am giddy, dizzied by the hammering of presses, the clattering of engines, the whirling of wheels. My head aches with the multitude of infernal noises, and my eyes with the light from infernal fires." Southey thought it was all metal bashing, but he was wrong. Coin making is all about precision. And he doesn't get more precise than this. That is this is Dad. This Janvier machine works like a pantograph. This stylus, as it were, traces the outline
From the master made of resin,
very gently, following the contours as it revolves round. It moves down and just comes over the bumps, transferring it in increments of 1/1000th of an inch onto this die here. It takes 27 hours.
Amazingly, this machine's been in action since the 1870s.
Precision and diversity. That's what made Birmingham's fortune. The city of 1,000 trades, the world's greatest toy shop. In those days, toys meant trinkets. Anything from buttons to pen nibs, watch chains, snuff boxes, bracelets. What do you want? We'll make it for you.
Birmingham's canal network was a huge commercial success. Shares in the Birmingham Canal Navigation Company were like gold dust. In 25 years, they went from £140 to £1,000. The city's traders were now taking advantage of international markets.
Gun making was one of the skilled trades that capitalised on the new links with the outside world.
Birmingham was the ideal site for gunsmiths. Raw materials and skilled metalworkers were readily available. Finished guns were shipped via Liverpool to the British Army in Ireland and America, or via London and Bristol to Wellington's troops in Europe.
This is the Bull on Price Street, which was the centre of the Birmingham arms trade. And at the end of the 18th century, when the flintlock had been perfected, Birmingham was the major arms producer in the world. Now, to make a gun, you need three things: lock, stock and barrel.
And they're still being made in the specialised workshops that developed during the Industrial Revolution.
So, the first part of the process is the barrel. I'm going to polish this one. So get that on the lathe like that. This is emery paper, but originally they would have used a shaped piece of lead, a lead lap, an emery paste in an old cup. And this is quite warm now, but with a piece of metal, it would have been hot. It's very, very satisfying and very exact in the proper hands.
Now for the lock. At Wesley Richards, they've been making guns since 1812, just in time for the Battle of Waterloo.
The lock, the precise mechanism that controls the firing of the gun. Lots of component parts here. These are all made by modern methods, but originally these would have been hand forged to shape. These are all assembled, the barrel is then added, and that's the kind of assembly you get. Incredibly detailed and very precise.
Traditional techniques are still used, like testing the fit with a smoke lamp.
This is all precision work by hand, which you can tell by the state of Ken's bench, because the only person who knows where anything is Ken himself. So, what you do there is you make sure your finger's out the way, introduce that into the mechanism like that, copper tool so we don't mark the steel. Okay, and then by seeing how much smoke's been removed, you can see how well it fits. There you go, it needs a bit of work down here, Ken. Not bad though.
The final stage is to put the lock in the stock.
And then the completed, handmade, precision Birmingham gun is safety tested. But that was not always the case. Birmingham had its cheaper end of the market. These 4 and 6 penny muskets, that's 22.5 pence. They were produced in their thousands. They went off in shiploads. They were produced for the barter trade. They were swapped for silks, furs and slaves. The unscrupulous manufacturers would plug the fire hole, fill the barrel with water, stand them up overnight, and if no water appeared by osmosis at the bottom of the barrel here, they were warranted. They were the sort of guns you were better off in front of than behind, because they generally killed the people who used them. Anxious to improve their reputation, a group of leading Birmingham gunsmiths paid for an Act of Parliament and the establishment of the Birmingham Gun Barrel Proof House in 1813 for public security. This is one of the most businesslike buildings I have ever seen. This Ned Kelly of a building is the proofing gallery, or black hole, and this is where the gun barrels were and are proofed, because if it ain't broke, don't fix it. So, these barrels would have been loaded with black powder to give 30% more pressure than normal usage, laid on these blocks, and when this house was in full swing, there would have been about 100 barrels along here. Black powder would have been laid in a charge, covering the breech hole there, ignited by a percussion hammer behind me, activated by a lanyard pulled through the hole in the wall. Then all the barrels would have discharged into the sand over there and recoiled like that, burying themselves in this back bank of sand. Very simple, very effective, and a fantastic building.
Birmingham's reputation was at stake, and a rigorous scientific approach to safety testing was the only way forward. If the barrels survived the blast without splitting, they passed. During the Napoleonic War, Birmingham produced 5 million guns in 11 years. With Birmingham's industries expanding on this scale, the canal network struggled to cope with the increased traffic.
Success meant overcrowding and bottlenecks. What was needed was a radical solution to cut through the meandering loops of the old canal. So Telford built this, the new main line, using aqueducts, embankments and deep cuttings. A canal highway. Galton Bridge, named after Samuel Galton, member of the Lunar Society and one of the original promoters of the canal, has a span of 45 metres over a cutting of 23 metres. Brave engineering for the time. The importance of communications to Birmingham couldn't be made more clearly than here at Spon Lane. We're on the Telford new main line. Towpaths either side. There's the railway line. Up there is the M5, and down here, almost lost, is the old Brindley main line on an aqueduct, meandering backwards and forwards across Telford's new highway.
Birmingham moved with the times. Traders kept a keen eye on fashions and trends. Better education meant there was an increasing demand for pens. Old metal stamping machines were modified to produce precision pen nibs. One manufacturer alone was said to be turning out millions of nibs a year. Birmingham's commercial success also boosted the surrounding towns, transporting their raw materials and fragile finished goods on the canals.
This huge web, the interconnecting canal system, you've heard the cliché, Birmingham having more canals than Venice, meant that outlying areas with their own specialised trades were included and provided products for Birmingham's shop window. This is Stourbridge, glassmakers. They got sand from King's Lynn, coal from the Black Country down the road, and they made it in these. This is one of the last surviving glass cones, and it's 26.5 metres tall. Good, isn't it? It looks like a funnel because that's what it is. Cold air through these tunnels, the bottom, is channeled by the warm air rising from the furnace to create a draft of air so that you get the temperatures up to about 1250 degrees C. Coal was fed in down here by a bloke called the Teaser, bless him. And that would have been the furnace there.
The Stourbridge Glassworks was still in full swing in the 1930s.
So in the furnace would have been pots of fire clay containing the mixture, sand, lead oxide and potash, to make lead crystal glass. Working all round the furnace in teams of 4, the men would have worked 6 hours on, 6 hours off. After having blown the glass into a bulb, the gaffer, the leader of the team of 4, would have shaped it here. Using tools like this, the Brucellas, still got their Italian glassworkers' names. Contemporary source said, the men and boys appear healthy and happy. They perspire freely until they seem to be in a perpetual bath, dealing rapidly with the liquid that seethes at molten heat. After the glass was made, it was winched on trays through the annealing oven where it was cooled and hardened. And after it had come out the oven, it was packed and counted, because in the 18th century, glass was heavily taxed. Even window glass.
The tax made having windows an expensive option, and it held back the development of glass technology. But when the tax was abolished, it was Birmingham that cashed in. Before the Industrial Revolution, crown glass was one of the commonest types of window glass, and there are still a few craftsmen keeping the old skills alive. First, you build up molten glass on the blowpipe.
It's so hot in that furnace and the glass is so molten that you can't actually see it. So what H has just told me is that you introduce your blowpipe and you take it in very slowly, which is why they don't just go douche like that, because the reflection of the pipe on the molten glass tells you where the top of the glass is. Smart.
Then you have to make a balloon shape.
Let me power. Easy, easy.
Easy, turning.
Keep turning.
Whoop. All right. Whoop, whoop, whoop.
A gentle blow now, just to fill it out. Right.
The balloon is then taken off the blowpipe onto a solid rod. To turn the balloon into a window pane, you have to spin it. By the end of the 18th century, they could get good quality panes cut from this disc, but they were still small.
In the old days, you used to keep the outside and get rid of the middle. Now they just keep the middle, the bullseye. That's that stuff they put in old English toy shop windows. But the Birmingham glass blowers developed another method. They blew a cylinder, cut it down its length and opened it out.
This technique, first tried in France, revolutionised the making of plate glass. Always open to new ideas, the Birmingham glassmakers brought in French experts to learn the tricks of the trade. Once the cylinder is the right length, you have to straighten out the end. That's my job.
I've got a thumbs up from H.
The glass is allowed to cool before being cut. Then it's reheated in the furnace. It flattens out to produce a broad sheet that can be cut into panes.
In 1850, the skills of the Birmingham glassmakers were rewarded with one of the biggest contracts of the century.
Nearly 1 million square feet of glass in just 10 weeks for Paxton's great exhibition building in Hyde Park.
As the editor of Punch put it, this was to be a crystal palace, a building of glass and iron, beauty, wedding strength, an industrial hall of nations. At the height of the work, Chance Brothers in Birmingham were producing 63,000 panes a fortnight. And all the ironwork came from the city. 330 columns, 2,300 girders, 24 miles of guttering. It was a triumph. Not bad for a bunch of Brummie metal bashers. But as the city's motto says, forward! You can always tell a Brummie, but you can't tell him much. In 100 years, the combination of entrepreneurial energy, skilled workforce, free spirit and a state-of-the-art transport system had made Birmingham the workshop of the world. Next episode, I'll be looking at how steel transformed the fortunes of Sheffield. I'm sorry, love, I've got to have 3 or 4 pints tonight, honey. I've been glass blowing all night.